Welcome back. We're going to kick off where we left off. This is a reaction to the Eric Weinstein and Terrence Howard discussion on Joe Rogan the other day, maybe yesterday. I did two. One of them is already blocked. It's possible the first one will also be blocked. I did dispute it over fair use. I did point out this would happen. I knew it would happen. People just like, no, I don't like it. I came here for affirmation purposes. Oh man, I've been getting shit. Some is justified. I'll say that. Like my voice. I mean, not to say that it's justified to talk shit on my voice, but I'm like, yeah, I know. I don't really breathe. I sound weird. I'm kind of hard to listen to, but I also see that as like good. Good. I'm glad there is almost like a filtration process to get to the goods. So, it was blocked though. The first one was not blocked. I was thinking about it. The first one I talked a lot. The second one, because I published it, people commented, oh, fucking, if you're gonna react. Don't just talk. React. Yeah, you haven't enabled anything to react to, but I have because it's the topic. So I was reacting to the topic first and foremost before even touching the play button, but people don't want that. Whatever. Some do. Appreciate it. Thanks, guys. But the second one, I tried a little bit to be a little more like, alright, let them talk more. Although I did turn this thing on, which is still sitting there. I think it's kind of fun. Nice little, why not? Something to look at. Maybe I could even do the opposite, where I go like this. Make this big. And then bring it down. Bring it down. Somewhere. Even further down, I guess. Come on, buddy. There we go. And then... Is that... Okay. Nope. This one. There we go. There we go. I'll make it bigger if there's something on the screen worth seeing. Okay. Down here. I put this on because why not? It's cool features. These are shallograms, if you don't know. They're something I have been studying closely that are very important. Hopefully, I'll try my best to not mute myself and then talk, because I did that several times, and it's always very frustrating. I imagine it's hard to watch when someone's just not talking because the audio is muted, but they're trying to talk.
Called the Mansfield Amendment, which got the military out of science, which was a disaster. There's a lot of things that happened.
But imagine if science took a wrong turn when it walked down the road of relativity, if in abandoning the ether. And now they've walked down this road, and now they realize that it's a potential dead end, but instead of turning around and saying, okay, well, let's use the luminiferous ether that all of these equations were built off of. And here a young man that's outside of the world has come in and said, okay, I have the wave conjugations that make up and prove the etheric nature, the etheric substance.
So
that's what I want to,
Jamie, if we could bring back
pieces.
the portal group page, I can sort of show what Terrence is talking about, what his geometries, how he relates them to the physical world. So if we could go up to Howard's unifications claim. Okay. So you say you've come up with the grand unified field equation. First of all, he's doing something very unusual. He's saying grand unified, which actually is less than unified, because unified would include gravity. But he's also drawing from a group, I think, called the electric universe.
No.
Okay.
No. I'm drawing from...
Thank you for saying that, Eric. I agree, although he's saying no.
Lorentz and Hein's work, when they were deciding, they were trying to prove that it was electricity and magnetism. They could derive...
I wonder if he is exposed to the electric universe, because he's definitely in the podcast with him alone. Definitely gave that impression. Okay, I'll let him describe his exposure, though. Pardon me. No, that's not what you definitely are. Electric universe.
Unified, which actually is less than unified, because unified would include gravity. But he's also drawing from a group, I think, called the electric universe.
No.
Okay.
No. I'm drawing from Lorentz and Hein's work, when they were deciding, they were trying to prove that it was electricity and magnetism. They could derive all of the effects of nature that we see from electricity and magnetism.
All right. So if we go down here, hopefully, because we just prepared this, by the way, shout out to Dr. Brooke Dallas, who put this together and just got her PhD from Caltech.
Congratulations.
Yeah, congratulations,
Hello.
Brooke. Okay. So all of this these four things are how the community that you're trying to unseat thinks about nature at its deepest level. Now, let me see. Is there anything under there? Maybe not. So go up to, let's do David Tong's, because you brought up David Tong. Okay. I think I understand this, and I'm able to talk to you about it. Is this something? So this is my community and how it thinks of everything in the world. All right.
Right.
Do you have a way of relating what you think about in terms of what my community has wrong? Does this mean anything to you?
If you remove gravity outside of the equation, you take gravity out, because gravity is affected. Gravity is actually covered by that strong electrical force.
Terrence, 1 second. This is not a gotcha. And it's
no,
not me.
I know. I'm just saying.
Do you know how to read this?
As best as we're talking about, I as imaginary.
Yeah.
You know, d to the 4. I don't know what the d represents.
So that's the volume element saying that you're in four-dimensional space and you're going to take an integral.
And y to a negative g, y to a negative gravity.
That's the determinant of the space-time metric with which you might have an issue. Okay? So in other words, you're normalizing, you're saying that if the rulers look one way or the rulers look another way, according to Einstein, you have to put more weight or less weight on a region of space. Do you know what that R is? That's the foreplay. And then in the parentheses is where the stuff gets crazy.
Explain it.
That's what's called the scalar curvature. So after Einstein did his big general relativistic field equations, that was like Einstein scaling the shear face of Half Dome. Hilbert walked up the backside like a week later and said, you know, you can derive your super complicated field equations from the simplest thing in the world, which is the scalar curvature. So when you say everything is curved, that R is the scalar curvature of Einstein's pseudo-Riemannian metric. And then, remember F mu nu? That's what we were just riffing on before. That's saying we don't know what to do with the electromagnetic stuff, so we're going to do the stupidest thing possible, and we're going to figure out how big it is and square that, and we're going to shove that into this thing to be minimized, which means make this as small as possible. So give me the configuration that gives me the least electromagnetic size. Then, because of 1954, a guy named C.N. Yang and his sidekick Mills, who didn't do nearly as much afterwards, said, you know what, the strong and the weak force are exactly the same structure as electromagnetism, and we didn't know that. So nature, in that first line from the R to the W, takes curvature 4 times, and 3 of those are doubled, like F, F, G, G, W, W, but one of them is singly in there, and that is really sort of the soul of the incompatibility, not what Ed Witten says about you can't quantize gravity. That's not the discrepancy. We've been lied to for a long time, in my opinion. What it is that the curvature that enters as gravitational and the curvature that enters as the internal forces, the nuclear forces and electromagnetism, occurs differently. One is Riemannian, one is Ehresmannian. The line below that, Dirac in that term, psi bar d psi, is telling us the kinetics and the interaction through minimal coupling of the matter with the force that's in the line above.
Right.
And then the last three terms are the fudge factor due to Peter Higgs, because we found out in the late 50s, a gal named Madame Wu, the Dragon Lady of Physics, told us that if you put cobalt-60 and let it beta decay in a strong magnetic field, all the particles come out spun one way. And that left-right asymmetry meant that you couldn't put in masses in a standard way for the matter, which is showing up as psi. So instead what we do is we have this thing, which is a field called the Higgs boson.
Psi is the wave function.
Psi is the fermionic wave function of the matter. That's the quarks, that's the electron, and that's all the neutrinos that are penetrating us all the time. That kinetic term, the DHs, tells us how this Higgs field will move. But mostly, you see,
I'm purely interrupting because it had occurred to me. I've been playing for a couple minutes without interruption, and unfortunately, the algorithm, I guess, that like monitors videos looks at the like amount of the content per content, it seems. So one thing I'm just thinking while I'm looking at this, I do not know these things very well at all, except for enough to understand that it's a best fit equation. It's kind of like doing an Excel spreadsheet and just putting an equation over the data. But in this case, it's one that has been proclaimed like the theory of everything. But it, like he's mentioning, a fudge factor, that is a like tactic, if you will, a aspect of a best fit equation. That like you add another variable and that adjusts the equation to fit the curve better, and voila. But it's not true. It's really just classical mechanics. It's just in an infinite universe that includes infinitesimal particles in an infinite abundance due to their infinitesimal nature, where the subtler systems are more abundant, like atoms are more abundant than planets, but ether is more abundant than atoms, than photons. It is subtleness. Approaches nothingness and approaches infinite abundance. And that material in a classical universe where all of the systems are functioning under classical mechanics laws, the laws of motion, just the laws of motion, not even gravity, just the laws of motion, yields gravity, because gravity is a outcome of two systems adjacent to one another that have this flow of this infinitesimal particles that comes from all directions to the objects. So when there's another object, it physically blocks a portion of the flow. So pressure is alleviated from that side. So it just moves due to the imbalance of pressure of the ether to create gravity. But the motions of those particles inducing that pressure are following the laws of motion. Just classical. Whatever this stuff is just a best fit equation that looks smart. It looks smart. It's got integrals, it's got derivatives, it's got imaginary numbers, it's got segments of it that are accounting for, but really just fudge factors. It even includes, I believe, somewhere in here is Hubble's constant, which is not true because the Earth is not expanding, or Earth, the universe is not expanding. Sorry, I'm so Earth expansion. I don't even think about expanding universe that I just phrase. It's not expanding, so that's actually true too. It's just it did expand. See my name, but the username that is Earth expanded. Anyway, universe not expanding. Hubble's law of increasing redshift per distance is not caused by expansion of space. Hubble's law was interpreted based on observation of galaxies, where every galaxy we see beyond a certain distance is redshifted per distance. And it doesn't matter what direction it is. And so we said, well, what causes redshift? Motion. These things are moving away. And that kind of made sense. That meant everything was back together at one point. Voila, Big Bang. But then they were moving really fast. They were moving too fast. What are we going to do about this? We'll just say this observation that we interpret to be caused by motion, that when we do so, leads to faster than the speed of light motion of galaxies at sufficient distances. Something is causing this motion to not exceed the speed of light, therefore space is expanding. Voila, we've solved the mystery, all the while not behaving like, not adhering to the purpose of physics. Physics does not, the objective of physics is not to add. It's not to be like gravity, electromagnetism, strong and weak interaction, and fifth fundamental force. Just the suggestion of another force. That's not how, like, the logic of reductionism of physics is, and to add expansion of space because of all distant redshifted galaxies in all directions, and the interpretation that it's caused by motion is not actually following the practice of science. It's unscientific. The thing is that redshift isn't necessarily caused by motion. It's also known to be caused by gravity. And if I don't know if I want to get into how gravity does it, because it may sound too unbelievable if I give too cursory of a description, but I guess I need to at least a point. See my As It Is Written in the Cosmos video, I believe number 5, 6, and 7, two of them, 5, 6, or 6 and 7, are the big assumption, and which is introducing the concept that we're just talking about, but in more detail. And then the second one, whichever that is, something to do with decomposing the models or something, decomposing the standard model or something like that. I believe I called it. But the point is, this is a best fit equation.
Imagine that in this room it's 69 degrees Fahrenheit, okay? You think that it's the same everywhere, but maybe where Joe is actually like 68.7, and over there it's 70.1.
There's a different frequency, a different
and
space.
so that H thing is said to have a VEV that varies slightly in the world. Vacuum expectation value, because the vacuum isn't boring.
Right.
Now that V of H, that is the potential term that you neglect every time you say that all energy in the world comes from kinetics. That's not true. And that V, and there's a portion hidden in those FFGGWWs, which is pure potential. That last thing, which is not commented upon here, is called the Yukawa coupling. And that last term is how the Higgs field gives the illusion of mass to the matter, which was prohibited from having a naked mass because of the efforts of Madame Wu and Yang and Lee, which is the same Yang of Yang and Mills. That thing that we just went through, which may have been boring to people, is the source of everything we know about the world at its deepest level, right? This thing right here, which might be called the partition function, is a Feynman path integral of this. And if you could understand what this is, we don't know of anything that isn't in what you're...
He described it to absolutely. This is. Are you sure it's not a best fit equation? That it is really just kind of hideous. Dear God. I mean, I don't disagree that there are elements of significance to this, and that it likely fits the data extremely well. I wouldn't be able to know how well, because I've never truly monitored the scientists on the matter. I gotta kind of just take their word for it that this is like fitting the data extremely well, at least what they're considering. So I'm sure like the Higgs stuff, like there's something to it, but it's like there's also like an utter disconnect from the reality that comes from this analysis. That is a best fit equation. And maybe Newton's laws are best fit equations, maybe in some way that don't always apply. I could envision like some circumstance where it kind of appears to be at an extreme case and not quite be correct in a way where it's like, oh, we need a new theory. Or something else. I could see something like that going on. Let's keep going.
You're seeing. It's a whoa. Can I get a whoa?
Can I get?
I live for this.
What now? Now this is the difference between having, they've been working on this for damn near 60, 70 years, but they don't have any physical models that represent any of these things. And if my physical models describe the electric force and the magnetic force and is able to account for all of the actions that takes place or the effects that we see, then it should be a better replacement instead of having to go.
Physical models. I mean, he's got that literal toy. I mean, I don't want to call it a literal toy, but that's what his patent says. I imagine if he has a patent on this thing, it's something of that nature in the language. I don't know what he's expecting. It is extremely, extremely difficult to overwhelm the reasoning of modern science. The only thing really capable is actual truth. Any other model that's just not true is going to lack the supportive evidence to overwhelm the also not true but highly supported models of modern science. It's impossible because there's thousands of people working on it across centuries. Well, really a century. The last century is when things really deviated. Like, we were on a path. Like, here's the truth. We were walking to it. And then we, ran into, nighttime, say, or something. Like, the sun went down. We couldn't see quite so well which way to go. And we decided to just go take another path. and we went some other way. Well, there's a road over there. That one has some light at the beginning of the road, and then we start going down that path. But it's like a forest, hard to go that way. Next thing you know, it's cliffs everywhere, and just like, what are we doing? Not just cliffs, but like the ground underneath is just thin layers of bullshit. So you step on it. Oh, I stepped on some poop. Oh, dude. Wait, there's a hole under the poop. Oh, man, the whole floor is poop. Oh, and then it just collapses because it's thin and there's nothing underneath because it's all bullshit. That's sometimes the case. I don't want to say modern science is like that. It's more like a solid that's not as solid. Like on the Mohs hardness scale, modern science would maybe be like a 6. But like the truth, that shit, it really, I don't think it has a number. It might be just
You didn't do that.
the pinnacle example of hardness. Cannot be penetrated, cannot be moved, cannot be changed. It is that which is. That shit is solid. Put that against modern science, then it might have a chance, even when it's one person. Because one person still is one person. It's a lot of shit to account for. Oh, this thing. Well, what about that? What about that? What about this? What about this? What about this? We can do this for a long time.
I did do that. Let
You
me
did
show
do
you.
it.
Let
All
me
right.
show
Okay,
you.
show.
Now it's time to show.
Okay, here we go. I really want a YouTube video of him creating these things.
I would love that. So,
Just you with an acetylene torch.
I want
whatever
them in
you're
glass.
using.
I want them in glass, brother.
Yeah, somebody needs to make these.
yeah, well, I tried to do that before.
Well, you know,
It
we
seems
have,
like someone
we
could
have a
3D
community
print
of
these.
mathematical artists. I want to hook you up.
I would love that. So this tetrian, as I say, begins the entire dance. It's I would call that would be Planck to me. That would be the proton. That would be the beginning of everything.
You map 4 different things to this. You say, 1, it's dark matter
I said
because it's interstitial. Wait, 1 second.
Okay.
You say, 1, it's dark matter because it's interstitial. 2, you say it's hydrogen.
it becomes it takes
3, you say, well, look, it's got 4 electric and 4 magnetic because you associate the faces with electric and you associate with the vertices with the magnetic. You say, you go back to Walter Russell, who has this whole thing about exhaling and inhaling, expanding and contraction. You know, it's a lot like Ecclesiastes. There's a time and purpose to everything under heaven. And then you say, because it's balanced as 4 and 4, it must be the weak force because there's no net voodoo on it. Okay? Then when you get to your, if you can bring up what you call the Huntian.
Hold on, let's stay on this one.
All right.
Okay.
I say that this right here, like nothing in the universe does nothing for a single motive. Everything has multiple purposes and accomplishes multiple things. This becoming the geometry of hydrogen, or the very first visible element, is as a result of all of those forces pushing on it. But the no, yeah, I can use another here.
Yeah.
I can use another here.
It's called explainer juice.
Yes.
All right.
Yeah.
So, thank you.
Thank you.
Thank both of you.
So, if we start with this as electricity, then we want to go to the very first phase from it. The first thing that happens to it is it decays. The first line of decay, and that first line of decay is literally just putting on 2 magnetic fields. If you'll hold that for a second, I've got to get something else out.
I gotta say,
Go ahead.
I love these things.
They're pretty
really,
dope.
they're really dope.
Yeah, you need a shelf in your office.
Yeah, for sure. I put this in my house, but Terrence, I just don't see.
We're not done.
All right.
We're not done.
All right.
So when you put,
Didn't you see the box he came in with, bro?
What kind of?
That
No.
box of stuff.
so when they line up,
Yeah.
then they begin to create, and if you lay it down on your thing, You can lay them down,
Yeah.
and you'll see them align. If you can.
I want to design a skate park around these.
A lot of sharp surfaces. These
but
are gonna get fucked up.
Anytime you're urinating,
Pardon me. Okay. I mean, interesting, but he's saying, like, these are the things that make up the universe, if you will. When really, what we're looking at here, these are much better representations of what we're trying to study than anything over there. Not, I mean, yes, there's something of interest, but to really appreciate the processes. What happened there? What happened there? Some of them tell us. Really, they all tell us. They all have a story to tell that reveals very important details about the subject matter that we're really seeking to study. Like, what is up with this small stuff? What is it like? What are they? What is an atom? What is it like? Look at shallograms. Shallograms have a story to tell. I don't know why it keeps repeating this one on the screen. I put many more in now, and then I randomized it, and so it should not be doing that, but...
Man is urinating, he sees this pattern where it's expanding and contracting, expanding, contracting,
Right.
that braiding behind the boat. This describes that motion from that. But then let's go to the next stage of decay. The next stage of decay would be 4.
How does a solid thing, like, of that nature describe its motion? Like, shallograms are solid things, but they have current flows etched on their surface that describe the motions of the currents, like so, that were integral in their formation process. These lines are not river etched, but are etched while the shallogram is forming and creating ammonites. Ammonites are formed in eddies that water and earth materials, in this case shale, pyrite, quartz, clays, and other things in the area of the Tibetan Plateau and the Himalayas in the Kaligandaki Gorge Valley area, Damodar Kund. These things are exceptional. Truly, to study the small, there is no substitute. No, those things on the desk in this podcast that can possibly reveal the actual nuances of processes that shallograms reveal. Look at the way that curves, like right over there, like it bent. It was down and then it kind of went off. Like, dude, what's up with that? I don't even know. I didn't notice that before. I'd have to look closer. Oh, like the line. What's up with these lines in the ammonite extending into the lines? It's because current flows are etching both, but in the case of an ammonite, they're forming an eddy, and that eddy flows a current to a center that then radiates outward around the eddy, creating lobes. As the pressure flows current into the eddy, it goes around the eddy to a center where it then flows around, because essentially the eddy is happening under pressure contained. It's not like it just forms an eddy. It happens when there's pressure containing it. So it's happening under pressure contained, forms this eddy, and then the eddy begins to penetrate through the pressure and cuts paths that increase the size of the ammonite and remove the material, so that the water that is flowing in the eddy and transporting the material of these shallograms has space to actually fill the current that is flowing in, until it actually breaks through the boundary of the stone, and the internal currents are able to flow out of the stone because it cut through, which is why they almost always, when an ammonite is in the shallogram, have a window into the stone where a matrix just has this opening, and then there's this ammonite with the chakras. Very much how things are.
Four sides. Now, what these are responsible for. Boom, boom.
How you doing, Eric?
All right, Joe.
Yeah, here we go. And this is
the hard part for me.
That's the fun part.
Okay.
this is the part
Watching you
I've been
squirm.
waiting for. This is the part I've been waiting for. Now let's put this.
This is an
in.
elaborate hoax.
Yes.
My whole
And
life's
I
an elaborate
should-
hoax.
Now I should be putting the patents up so that everybody isn't out there saying, you know, this isn't his shit. But so when you get to this level
Yeah.
of decay, they start to come together.
This is funny. I feel like you guys are trolling me. I can never know unless you actually are, and then you tell me. That's the only way. If you're not, then I can never know. And if you are, then you have to tell me. I mean, it's just totally a group choice. I mean, it's a conspiracy. It's bullshit. Just trying to make me do this. You're making me do it. Just trolling. He's doing it. We got him to do it. It's a go. It's a go. He's fucking it. Look at this. It's how stupid he is. Fucking A, man. That's life for me. Maybe for you guys. I don't know. Can't know.
And they create this natural.
How gorgeous
curvature.
is that? Look at that.
But do me a favor, they also create these spaces, and if you lay them out, one on top of,
Well, I'm still riffing on this one.
well, you're about to see that interact with the other side. Like we came to play today.
Boy, nothing like these conversations make me understand how different people's brains work. There's just different humans out there.
Here we go. So, all right, let's, if I can move some of your stuff.
By the way, I just didn't know what I was getting.
Yeah.
I brought like some weird tools in
So
case we're
lay-
going to make weird
like,
points.
So if you're laying these
Yeah.
out, you're starting to see this pattern. But what's interesting, these have chirality. These
Yep.
spin in opposite directions from each other, but they ultimately reform together to fully tell that story.
So this is why category theory is so powerful, because your analogizing brain, I mean, let's be honest. I want everybody to form, without saying anything to each other, what is this most similar to?
The DNA.
Right, I was going to say the same. Right? And if it was DNA, what would be the interstitial between these two things?
That would be that ladder. Each line, it would be the
hydrogen.
ATCG, the hydrogen.
That would be the hydrogen bond.
It would be phosphorus, oxygen, oxygen.
Now, if I was a protein scientist, what would I say this was?
You would say it's a ribosome.
I would say it's an alpha helix.
Oh.
Right? I would say this was secondary structure in protein. So my claim is that one of the reasons that Rosalind Franklin didn't actually get to the double helix is that she was a really good scientist, and Watson and Crick were not good scientists. She said, look, I can see right through you. You just found out that Linus Pauling figured out the alpha helix in protein, and you wannabes who don't know jack shit about biochemistry want an alpha helix. And you want to do nucleic acid as an alpha helix, and look, based on the X-ray crystallography of the Maltese cross, you're going to try to shove DNA into something so you get to be Linus Pauling all over again. I don't want any part of it. And the problem for her was, helices are ubiquitous at all different levels, right? So in other words, Watson and Crick didn't own the double helix. What happened is that a very common structure that's going to come up over and over again, it's going to come up in viruses, where you have helical viruses. You have it in protein. You have it in nucleic acid. That structure is because there's a platonic form, which you're finding here. You're going to find helices over and over and over again because you can't really have nature stop finding this structure. It doesn't belong to any instantiation of the system. And so everything is going to rhyme. Now, your big problem is that everything rhymes to you because you know a lot of stuff and you know a lot of similarities. Your brain's very good at that. And what your brain is not very good at is pruning the amount of rhymes that it sees.
Well, what I'm saying is this is defining all motion. We just define the motion behind the boat. We just define that other aspect. And remember I was saying about the Huntian being a massless particle. It only exists as a result of these 4 to 8 tetraons pushing down because of pressure. The moment that these 8 tetraons disappear, that interior space, it's no longer there. Okay. The moment that is.
What pressure, though? Just pressure? Already there's an issue. I mean, we're talking about how things are induced fundamentally.
I don't know how to stop you from doing this.
I hate doing that.
Well,
I hate you stopping me from doing what I'm not supposed to be doing.
No, I don't. I'm so far out over my skis. I promise you what the internet is going to say the next day about me is, Eric Weinstein sees blah, blah, blah.
Don't read the internet. Stop reading the damn internet.
Okay, what I'm trying to tell you is, you're taking all the good stuff that you're doing, and you get into 19, and you're saying, hit me. And each time you do that, I want to slap you and say, don't do that. Because even if what you're saying is true, let's imagine that we find some structures like the ones you're talking about in wave fronts, right? I think what you're doing is totally canonical, and it's very, very natural. And I think you're building models, and you don't know how to do the algebra, probably, and you probably don't know how to do the differential equations, all that. Fine, I can point you to books, I can try to help you.
I'm a geometer. I like doing geometry. I would love to work with a mathematician that can define and redefine these spaces and write new axioms if there's real axioms to be made from it.
The world will do that if it's true. He's justified to not want to do all the damn work if the theory is true. You don't want to do everything. It's a lot of work. Thousands of people. I mean, it's thousands of lifetimes. You can't do it. So, like, at some point, someone's got to participate besides the theorist. So I understand his position, and to not really want to do it, or even maybe feel like others could jump in and do it. But that seems like a tendency he has. Because, like, let's say someone did it. Someone comes in and does it. They email it to him. They're just some dude. Like, hey man, I came up with this. He's like, oh. So I put out, and this is what we got, and then next thing you know, it's just these are the equations. These are his equations, practically. You know, like, it's concerning given the history, Terrence. Anyway, let's go.
Or postulates to be made for it. That's what I wanted to do with with Dr. Tyson.
Okay, but part of what you're doing is you're coming into another community. Like what you said about David Tong is so unfair to David Tong.
What did I say?
David Tong. Okay, first of all, do you know who David Tong is?
I know him on the internet. I know, but I've watched a few of his things. Okay. I was very impressed with it. That's why I reached out to him.
He's amazing, and I have my difference. He's an acquaintance of mine. I haven't seen him since 2011. Okay, he's an amazing treasure. Because that guy has a gift for explanation in our community, and in a world where a lot of people in string theory have lost complete touch with reality, right? This guy knows every aspect of physics so well that he can explain it with razor sharp clarity. So he's an absolute, he's a national treasure of the UK.
And I reached out and I said to him, look, dude, you're talking about these 16 fields. I said, I have the models for your 16 fields, which was
you're teaching.
Yeah.
That's okay. If you want to say, I don't understand this, you get a positive reaction from us. If you say, I have something and I'm not quite sure what it is, can I get an evaluation because I think I might have something? You should be able to get something from a guy like me.
And that's what I did. I went to Oxford.
I know.
Didn't get that.
But I'm trying to say something.
Okay.
Then you do this other thing, which is you teach. And your teaching is not good. You tell us stuff that's not true, that we can tell is not true. And then we say, okay, I can throw out the entirety of what he's saying.
What did I say that wasn't true, though? That's what I'm, I
well,
mean,
1 times 1 is not equal to 2. Let's start there. In fact, I'm angry at Joe because Joe should have pushed back on that. Joe is in awe.
The calculator says 1 times 1 doesn't equal 1 because of that square root of 2
Can we pull the portal group back up?
There's a lot of wild shit I don't push back on if I'm not sure what the fuck that person's saying.
I understand.
That's why. But also because I know that people are going to eventually respond to it.
Oh shit, Joe was not happy about that comment. It's like, hold up, man. Yeah, I should have maybe, but I didn't because I knew everyone else would. So, I think he did just fine. He doesn't have to push back. Maybe he accepted it a little more in ways that seem just from the positive praise. That would maybe make it appear like the combination was kind of like what Eric was saying. But, at the end of the day, people can figure it out themselves. He doesn't have to do it. He doesn't have to be the one. I mean, not like he's trained to be doing what he's doing. He's just learning as he goes. And really being a model host of a podcast, I mean,
but right now we've got a crisis where nobody knows what to believe in. Unfortunately for you, you were in a bad spot because you wanted to have fun. You had a show and it got really big. Okay?
That's why you're here, Big Daddy.
Okay, wait.
I'm saying people have...
Can we go to the Terrence product, maybe below that? I think you were in the right place. Yeah. Okay. Here's how we would do this in mathematics. Assume you were a colleague, right? And I wasn't trying to get rid of you and get you out of my office. I'd say, okay, no, I'm not. I'm not kidding.
I know you're interested and want to have further conversations. So go.
Okay. Standard thing, what we would do is we'd say, okay, wait a second. I don't really buy your claim that 1 times 1 equals 2, but let's try to evaluate what you're saying. Then I'd create something called the Terrence times binary operation star sub t, and I'd say that provisionally I define a star sub t times b to be equal to a times 1 plus b because your rule says that you should add a to itself b number of times. So that is the formula in standard mathematics for what you are introducing as times. Then I come up with the Terrence root of c equaling d if d Terrence producted with itself equals c. So now I have Terrence binary operation, Terrence root, and the Terrence square operation. And I say now, okay, now that's a totally legitimate object. Until you try to blow away times or multiplication in the normal sense, Now what I've got is I've got a new operation, and I want to know its properties. Is it commutative? No. A Terrence times B is not B Terrence times A. Those are two different numbers. Then I ask, is it associative? Yes, it's associative. So now I'm trying to make standard math out of the crazy ass shit that you say when you go to Oxford. And this is how I would start to understand it. I would say, Terrence, do we get anything new out of Terrence times Terrence root Terrence square? And I would therefore not incur the penalty that you're incurring. The penalty that you're incurring is when the rest of us work our effing asses off. And you come in and you say, I've developed, like, imagine if I got on this program and I said, is John Jones out there? He's a huge pussy. He doesn't know how to fight. I have a one-touch technique. And if I lay a pinky on John Jones, you're going to see a quivering little pat of butter. Sean Strickland has no disciplines. Guy's a big fatty. It's not going to go well.
No.
Okay. So what I'm trying to get at is, that's what you're doing to us.
I didn't mean to. That's not what I meant to do. But in me saying 1 times 1 equals 2, like I said, that's a metaphor that there's something very wrong with the math, because math should not be done.
There's nothing wrong with the math.
I'm saying the math that we are doing is still based on linear projections, even though we are in a multi-dimensional space. And if the square root of 2 didn't have that problem...
Terrence, listen to me very carefully. Assume you have the most beautiful curved linear object.
My wife.
Yeah. Can we do it?
I have mentioned this before, the number circle. Instead of a number line, a number circle that basically loops back around, so that when you go from 0, 1, 2, 3, 4, 5, and instead of just ... coming back the other way, it literally loops as a circle, and then has like maybe half infinity or something at like a point, and then infinity though at the 0 point. Like it goes from 0 to infinity, which is the 0 point, to infinity, 0 point, infinity, 0 point, infinity, so that if you go to infinity in this way, it's going back to the starting point in essence. I believe that was what I was thinking in the past. I might have messed up with that, actually, with the negatives. Yeah. Infinity, negative infinity. What is going on with those? I forget. I forgot the number circle. Now I'm describing it. I forgot it. You get the idea. I think it might matter in cases where, like, undefined happens, or like the limit goes one way and then abruptly it comes the other way. It's like those aren't really connected. Yes, they are by the circle. They're connected through the circle. That's why they're connected. The circle threads them as one. That might actually have an application in math, where there is some lacking in modern math. Maybe. I don't know. Just a thought. But I can't envision anything other than that. Math as it is pretty much like, what do you want, dude? It's simple. It's like the simplest thing. Like algebra. I mean, it starts with arithmetic and so on, and just builds from there. So it starts with really, really basic things and builds up until it runs into Isaac Newton, at which point it's like, okay, not so basic anymore. But hey, who cares about Isaac Newton's contributions? Einstein's probably right. Certainly that other dude couldn't be right. He had books about Bible prophecy. How could he know what the hell he's talking about? Certainly Einstein is correct, and the universe has no obligation to make sense to you. Okay, but it does make sense to me, so yeah, obligation or not, it does. So sounds like a you thing, dudes.
I don't want to talk about. I don't want my words about. I saw what happened to Will Smith. I want to keep your wife's name out of my mouth.
No. You'll meet my wife. She's very beautiful.
I'm sure she's dope. Okay. If you take the most beautiful ski slope you've ever been on and you imagine it was perfectly groomed so that there's just all it is smooth, you cannot create nonlinear smoothness without giving rise to something called the tangent bundle. And the tangent bundle is made up of linear objects. The nonlinear includes the linear. And it actually goes with your philosophy, which is that everything is an action and a reaction. The nonlinear creates the linear, but the linear encodes the nonlinearity. So if you actually wanted to practice, if you wanted to get as high as you could on Walter Russell, you would not try to deny the linear. You would say that the nonlinear is part and parcel with the linear, and that creating the nonlinear requires creating the linear. The differential operators at a point on a nonlinear structure form a linear space. And that's how we encode the tangent bundle when something doesn't sit inside of something else, because you hear that the universe is expanding. You say, well, what's it expanding into? Well, what we do is we encode that expansion without having a structure around it, no ambient space, by saying that the differential operators at a point are linear. So we've got an entire language that you don't know about.
But let's unpack that.
Sure.
For something to be linear, something to be straight, that means that it is no longer having to deal with the equal and opposite forces that nature puts on everything. Because the greater the action, the greater the reaction, greater the reaction, greater the resistance, greater the curvature. Everything in this universe has the resistance, and that's where the curvature comes from. So when they talk about, I don't mind them trying to go in a straight line or but the curvature of the universe is that phi at 1.618, that expansion aspect of it. That's the only consistent thing that you see in everything in the universe.
All right. If you take the concept of why is the cosmological constant almost zero?
I have no idea.
Well, nobody really knows. So you're not alone.
I mean, and them saying that the cosmological constant is zero, which means...
Do you know who Jim Gates is?
No.
Jim Gates.
Could you explain what the cosmological constant means?
Can we bring up the Einstein field equations with cosmological constant?
Is that the
Oh, this one is the one with the cosmological constant. I was like, where is it? There we go.
The dark energy.
That's that dark the quantum field that they, not the quantum field, the, what do they call it, the the vacuum.
All right.
Is that the vacuum?
So let's pull that one. No. I like that one. Okay. So that arm you knew is the Ricci curvature. That is a sub packaging of the full curvature. So you throw away a piece, like filleting it and you throw away the Weyl curvature.
Plus a bivector.
Well, these are symmetric two tensors. Sometimes people call it bivector. I find that terminology confusing. But yeah,
Okay.
you're in the right neighborhood. That lambda is what's called the cosmological constant. And there's a raging controversy as to whether that thing is a number or whether that thing is like the temperature, which might vary subtly. And this was this thing that where Einstein supposedly said his greatest blunder was to put this in. He then found that you need this because Hubble shows that the universe is expanding. And then very recently, in the end of the millennium, they said not only is it expanding, but it's expanding at an accelerating rate. And that's when this whole dark energy thing really took shape. That thing, and where was I going with this? Oh, yeah. Jim Gates, who's probably the...
Okay, it's not only accelerating, but accelerating at or not only expanding, but accelerating at not only accelerating, but accelerating at an accelerating rate. Is that what he said? Or expanding, but accelerating. The redshift per distance is accelerating at large enough distances to a point where it's not linear. So this is a funny aspect. So that story I told earlier where they took the redshift per distance and said, well, motion, and then realized, oh shit, we need to insert something to explain this expansion of space. In order to do that, they had to say it is basically a law of the universe. Expansion of space, it's a thing. It happens, and how it happens is linear. Like it's not expansion per space. Like, it's not something that is variable because it's a law. Laws don't change. Laws don't change. Oops, they changed. What happened? Oh, it's because it's a correlation and not a law. That's what happened. It's not a law. You called it a law to make it able to be introduced as some fundamental thing to explain the observation, but that doesn't make it a law. The reason it's not linear is because it's a correlation, increasing redshift per distance, but in a specificity, gravity. See those videos. See the videos. I explicitly explain it. I'm not going to explain it here because you got to see those videos. I can tell if you're seeing those videos, so if you're going to be like, hey, you don't know what you're talking about, I can be like, let's see. Oh, no views on those videos, huh? Or I can even be like, let's see. Oh, view. Oh, look. 30-second view, huh? Looks like you didn't listen. I mean, I guess you could turn it on, hit play, not watch it, and then comment, oh, this is terrible. There. Or you can watch it, not listen. If you watch it, though, you will see it's only reasonable. I mean, perhaps not true, but very reasonable. And the only way to know for sure is if the scientific community gave a shit. I've found supportive evidence. I've found an Einstein cross of galaxy clusters. People don't want to see that supporting evidence. No, that can't be. Oh. Alright, whatever. We'll see.
Finest African American physicist we have. Brilliant guy at the University of Maryland College Park. He's a string theorist, so he and I are naturally like Montagues and Capulets, but he's a lovely guy, very brilliant. He says, look, we need supersymmetry because that thing should blow up, and it's almost zero. And the only way that it's almost zero is because the bosons and the fermions, if supersymmetry is true, have to be balanced, right? So imagine that you had two gods pushing on a door, and they're of exactly equal strength. The door doesn't move practically at all, not because they're not powerful, but because they're perfectly balanced, like unnaturally balanced.
And it's what happens when an irresistible force hits an immovable object.
Well, but these are two irresistible forces pushing in different directions and creating the immovable object between them, to carry through the analogy. So that thing has to do with a balancing between two incredibly powerful but opposite structures. And I think that you're negating the idea very often that you can have perfectly balanced things through fine-tuning issues. Now, one of the fine-tuning issues that we don't talk about, we usually talk about them in physics, but the most famous one should be the one in biology, which is before we had DNA, there was a guy named Erwin Chargaff, and he gave Watson and Crick the worst peer review in human history. He said that these are two idiots, that they were pitchmen in search of a helix. They didn't know anything about chemistry, and he totally dismissed them. He is the guy who figured out that the amount of A was equal to the amount of C, and the amount of T was equal to the amount of G. And the only reason that that's true is because of hydrogen bonding that fixed the amount of A to be the amount of C on the other side.
Cytosine,
that's right.
guanine, and thymine.
And so the idea is that that was the fine-tuning solution. Why did you always have equal amounts of these things? Oh, because you didn't see that they'd been paired in a helix. You just saw it once it was broken. But the actual nucleotides had been paired, and so they're always the hydrogen bond enforced that. One was a double bond, one was a triple bond. This is like this. We're trying to figure out why lambda. We would understand better if it were zero, or we would understand better if it was enormous. The fact that it is almost zero in a world where the vacuum is filled with crazy stuff, to your point, this is one of the greatest reasons for, this is probably the greatest, I agree with Jim, this is the reason for supersymmetry. Without supersymmetry, we don't have an explanation for why that thing doesn't blow up.
So because you accept expansion of space, which is not true, we have supersymmetry. No wonder we're lost. trying to fit the wrong key in the lock. Maybe if we shave this part off. Yeah, I don't. No. Wrong key.
If you saw a geometric structure that defined and worked together completely, would this qualify as a supersymmetrical system?
Well,
and we haven't even got to the magnetic field yet, but you see how these things fit together and what they might do in replacing.
So you have a metaphor, and you have a metaphorical mind. So you have this thing that you call what's the tetrahedron one?
The tetrahedron.
Tetrahedron. You got one called the Huntian.
The Huntian, that's my son.
Okay. And then
The
you have
Aubrian.
you have a different one where the Huntian is flanked by two tetrahedron, which you call a transformer because it's
I call it a light unit.
Down.
I call that
then
a light
it's
unit.
a photon.
Yes, it's a step up and step down
and
transformer.
then here's how your unification scheme goes. You say, look, I don't need gravity because I simulated Saturn without gravity. By the way, electromagnetism looks very similar to gravity, which causes all older
That's what
electrical
I've been saying.
engineer.
Electricity is the cause of gravity. Gravity is an effect. It's a draft, like the thermos.
Will you
is a
stop
draft of
teaching, man?
radiation.
You
I'm
gotta
sorry.
stop teaching
I'm
because
just
you're saying interesting stuff and then you just always go over. Look, you want to know what the DMT of this stuff is? I'll hand you the stuff that'll blow your mind. Right now, where this is something called the double copy. The double copy is a relation that was totally unexpected between the amplitudes associated with gravity and the amplitudes associated with the Yang-Mills stuff. And I just met with a guy, Zvi Byrne, at UCLA, who's one of the guys who brought us this double copy. And it's a great mystery. It's like looking directly into the equimolar relations before you have the double helix. So there is a relationship that is much deeper than the superficial relationship between, can we bring up the Newtonian force of gravitation?
And then let's do a bathroom break.
Sure. We could do one right now. Do a bathroom break right now.
Yeah.
We'll be right back.
No.
You don't know who he is?
No, the last 3 weeks, all I've been doing is watching your shit.
Bob
Watching
Lazar.
you. I'm like,
Me?
I'm like, let me see what.
Oh, man.
Bob Lazar was a guy
I
who
caught you on
claimed.
TMZ suddenly talking about me. It was like, what is my name doing in Terrence's mouth?
That's hilarious. TMZ asked you a question
Yeah,
about
and
him?
they said,
That's
do I
hilarious.
have anything going on? And I was like, yeah, me and Eric Weinstein. I said Weinstein.
Stein.
I said Weinstein because Brian Keaton said Weinstein. He said Weinstein.
Weinstein
on his
is
way.
Weinstein,
He was
not
being,
Weinstein.
Yeah.
Yeah.
So it's Weinstein. So I
whatever
said
Harvey
Eric
is.
Weinstein.
Keating said
Yes.
Weinstein? Is that what you're
Yes,
saying?
he
Keating
said
said it
Weinstein.
wrong?
No, he said Weinstein. So I thought I said Weinstein, but I didn't know if that was just a joke or a play on
They got
things.
super
or-
sensitive after Harvey.
Yeah. Shoot, I don't.
So what we were talking about was Bob Lazar, who's a guy who claimed to be back engineering UFOs for the government back in the late 80s. That's what we were just talking about.
I did see something about him.
Yeah, he was on the podcast many years ago. It's a fascinating story that I hope is real. And that's what we were discussing, like whether or not Eric could make sense of it. So that's what we were talking about. We walked in here. What were we talking about right before we went for our bathroom break?
He threw up an equation. Not threw up. He
The
put up
Newtonian, and then what was after that? We're about to.
We're about to do the analogy between
The way those ammonites align. I don't want to point it out, because it's kind of this thing on the screen that people are going to be like, what the fuck? But, the way they align is not how fossils align. It's how eddies align, how currents align, because they're etched by currents. They're not fossils. I've proven it. See my live video, last one, the shallogram zone, episode 6. One of the shallograms in there, really 2 of them. I think I talk about 2 of them. Maybe a third or a couple more, but mostly 2 of them that I talk about are both unequivocal proof. The details I go through are unequivocal proof that shallograms are not fossils. Let me just show you one. Or maybe even 2 from that video. This one. Specific details are current flows out of the rock here in an eddy, though in a way where it's like eddying, as well as goes this way and eddies in the rock, but then flows over here, creates this, creates this, creates this, creates this, creates this boundary, goes over here, creates this, goes up here, goes around this chakra that it creates, where due to current pressures flowing in from the other side, pressures over here that bend it back this way, and then it bends back, comes back this way, interacts through this region to create a recessive ammonite that has the chakra as part of its structure, with this lobe out this way and this structure out this way and this extension over here that's not contained to this boundary but is instead related to this structure, all of which are in the rock. I'm not just drawing these on the rock. These are things that are there. So for comparison, like we can see these ribs here, these things, these that then go out, and there's this bubble type thing in here that then around it goes around across. The way this goes across is like right towards it, it points at it, and then it kind of has like a corner, and then wraps around where this region has a surrounding. We can see it up here, around here, around up here, across this way, and then back, surrounding like a node, which probably happens in other places, but that one's the most apparent, etc. And then this one, which doesn't seem like much at a glance, in terms of proof that these are not fossils. It looks like a fossil. What do you mean it's not a fossil? It's got ridges here. Okay. I've now gotten enough details together to conclusively prove this is not a fossil. I challenge any scientist, I don't care who you are, to disprove what I'm about to say. Go. Good luck. This is not a fossil because... The end? No, I'm just kidding. Let me find a good picture. Because... Oh my god. Guess we'll go with this one. If it opens... What is it? Okay, there we go. So we've got an entire ammonite structure right here. The boundary of the structure is limited to the top. The dendritic boundary that happens like over here. So basically what I'm saying is down there is one of these. Like the boundary of an eddy of an ammonite. One of these types of structures at a boundary, just not as eroded, more like this one, but where it has the full boundaries of its height. It's not taller. And we can say that with certainty because when we look from above, here we see these ribs. So it's lower. In fact, it is halfway. It's limited to exactly the halfway point. But someone who's saying this, well, ammonites can shrink at the end. That's all. Can ammonites shrink at the end and have once been larger? That is the question. Boom, headshot. Why is there a boundary there? Looks to me like if it was once smaller, the boundary of the ammonite should be down here. What? It's literally over here. So this has no capacity to imprint this boundary up here in its own region above it, where it should be. Like it's doing it like here. Well, not there, but like underneath here, for example, and like under here. Like it's interacting in a way where this is a negative imprint of the ammonite down here and a negative imprint up here. So it required the ammonite to be capable of inducing a negative imprint of an ammonite shell that conclusively, irrefutably cannot induce it. Ooh, it is something, this thing. I hope you guys been able to see this. Okay, good. I did have that going, so maybe that was covering it, huh? I'll just hide that for now. Now that I'm talking. Also, another thing I noticed is this thing is small. Like, it's kind of like this full size. Like, its boundary is kind of here. Its boundary is kind of here. And yet the ammonite imprint extended all the way over here. So again, in the same vein, this structure extended over here and up here. So it was basically a full ammonite structure. And then what I'm saying, pressure after this formed up here, like once the ammonite was forming, the process was undergoing. It formed an ammonite incurrence in this stone, in its materials, because it was still fluid enough to be doing this under the high pressures and currents of the flood. I know. And then the pressure of another shallogram was applied to its surface energetically. It's not randomly. Positionally, it was applied to its surface in a way where it too had an eddy, probably like this. Let's see, kind of like this one, like off to the side, not centered. Notice its boundaries there. This points at this boundary, this points at this thing, and this one. There's all sorts of relationships in ammonites in shallograms like this. Or like this. So essentially, another structure of another shallogram was against it here, pushing into the structure and bending it in to a point where it stabilized with a smaller lobe down here and reshaped the material. So it once had the outlets up here where current was flowing out from the center along these channels outward, etching them around the eddy that is flowing and out, but etching to create ribs, because that's how these ribs happen along the boundaries like this. Like the current comes out of here and goes along the surface of the stone under pressures where it's held to the surface and goes back around to the other side and vice versa, etching the ribs of the ammonite structure. So over there, it was once coming out up there, but then it got redirected by these pressures, pushed into this area to go down and then come out over here instead. Okay, back to what we're doing, pardon me.
Electromagnetism and gravitation,
Right.
Newtonian gravitational
Okay.
force law. So we have these inverse square laws, and because of the similarity, can we do the electromagnetic force law with two charges separated by a distance of r? Joe, who has smoked weed in this while we're waiting for it? Okay.
Nobody.
Okay, just Elon. He's the only one who. Okay. So if you look at, let's do the electromagnetic, the Fe equals KQQ over R squared. Yeah. Okay. So fix that in your mind and imagine that I turn the Q1 and the Q2 into masses and the R is the distance between them. and that K becomes a different constant. So now let's do Newtonian gravitational force. Okay. You go above? Yeah, let's do the one with the two big spheres right there. So you see that it's like very, very similar formally, right? There's a constant in front. There are two different objects, and there's a distance. So one of the reasons that I wasn't, I have the same feeling you do about that Saturn hexagon. Like, what the hell is that? It's unexpected. And I've never understood this great red spot on Jupiter being if it's a gas giant, it's so stable for millennia. The whole thing doesn't super make sense to me.
It's going to give birth to a moon.
Okay. So partially what happens when electrical engineers get older, they start to have this idea about electricity and gravitation. And you get this stuff about electric gravitics. Sometimes people call it gravidodynamics. And the formal similarities between these things appeal to people, and they want to see one as the other, right? And of course, the Kaluza-Klein theory tried to connect gravitation and electromagnetism super early on. So part of what happens is that Terrence tries to say, look, I keep coming up with these ideas of somehow wavefronts. The wavefronts create these shapes that are related to the Platonic solids, but curved linear versions of them. He associates the tetrahedron with the weak force. He associates the octahedron with the strong force. He associates an octahedron flanked by two tetrahedron, all curved linear on opposite faces with the photon, i.e. electromagnetism. He replaces gravitation. Then he says, weirdly, that he has a grand unified theory because he doesn't have gravity, so he doesn't need to put gravity in because of the similarity, and then he's got these shapes. And the disconnect is between the shapes and invoking forces, right? In other words, there's a moment in the story in which it's just this massive leap.
Yes, I'm purely interrupting just because I need to make sure that if that matters, that it will hopefully not like treat this as not fair use. Maybe it monitors and has some determinant on what's fair use, depending on how much the person's talking. So, valid point. How do we get from there to these things and carry on?
From the shapes, creating force?
Well, it was the issue in which I tried to show you the Lagrangian inside of a partition function for encoding everything. And in order to unseat, let me just give an advertisement for the establishment.
The Lagrangian, most of the time when people hear Lagrangian, I'm just saying this for the Lagrangian points are those points in space where the magnetic fields meet up into where there's almost a balance.
Same cat, different issue.
Okay.
Like when ZZ Top is singing about Lagrange.
No, that's what I was saying. When most people hear Lagrangian, that's what they're thinking is Lagrangian, but I'm sure you're thinking about something else.
No, I'm thinking about an objective function. I'm thinking about something to be minimized. In effect, normal human beings think about physics in equations, like Einstein's equation or the Schrodinger equation or all this kind of stuff. Physicists don't think in that way. And if you permit me an analogy, imagine you have four forces. And the four forces are analogized to the four different configurations of the Beatles. When Ringo is singing...
Darn, I was going to say, can you see the physics in that last one? Just envision like a cosmic spray. I could, I don't know.
Octopus's Garden, he's in front, everybody else is supporting, right? So when it's Well My Guitar Gently Weeps, George is out front, Penny Lane is going to be Paul, and Strawberry Fields is going to be John. Those four different configurations of the Beatles are all the Beatles, but they're different configurations, right?
Yes.
And the equations are like the different configurations of one person in front and everybody else supporting that person. But the Beatles is like the Lagrangian. Right?
Okay.
So the Lagrangian is a machine for creating those four configurations. Now, in the case of physics, right, you have these different equations for the different fields. The gravitational field equation has gravity in the metric out front. The Yang-Mills equation.
I just was realizing I should give a shout out, Sri Rudram. I get all these from Etsy pretty much, and Rudraksh Guru, the Shalagram images. Rudraksh Guru, who does not have any new Shalagrams that I've seen since I last came here. This one's pretty interesting. It's I mean, they're all interesting, but the way the surface is, it's kind of odd. A little more of a surface erosion paths than usual. It looks like it wraps around, maybe. I don't know. Hard to say. Maybe going that way too. Can definitely see some stuff in this surface. I don't know. Anyway, there, Etsy, I'll just go like this. Mangulum Jewelry for sure, who all these favorited ones are pretty much. Tadfa Jewelry probably at times. This is where I get these shallogram images. Enchantica, probably got some from the Shiva Lingam shop. Just so I can reference them, at least vocally. I do reference them usually, like, put their shop link, but I'm not sure which ones I put in there, unfortunately, so it's probably mostly them. And maybe Vedic Vanny, another one. Let's carry on though.
Has the photon, the gluons, the WZ particles out front. The Dirac equation has the matter out front, and the Klein-Gordon equation with potential has the Higgs field out front. And those are the basic fields of reality, so far as we understand it.
But the Higgs field is responsible for like 1% of the force applied upon them, right? It's so that I understand the Higgs field.
The Higgs field has to do with the fact, like, none of us are zipping off at the speed of light, yet we're all made of matter that has an asymmetry due to the weak force. If the weak force was not around, we would not need the Higgs force, and the Higgs field to generate an as-if mass. But because of the asymmetry built into the weak force, which is the only thing that has this left-right asymmetry, we can't have normal mass. There's a place to put a normal mass in the equation that's forbidden if the universe is left-right asymmetric. This has to do with this thing called the tau theta puzzle from the 1950s. We were freaked out. Can we get a picture of Cindy Crawford?
That's a good transition.
No, it's important.
Like it.
So, by the way, I'm dating myself because, okay.
How old are you?
What?
How old are you?
58.
Okay, you got me by 3 years.
Well, you said you were a young man. I was flattered to hear.
55,
Okay.
so we're good.
Now let's notice how beautiful this woman is and the fact that she's asymmetric, right? And the asymmetry has to do with a mole that she didn't remove from her face. So we can tell when you have an image of her, like if she wasn't holding a can of Pepsi and she wasn't next to a Pepsi machine, you wouldn't be able to tell, but for the mole, whether you were looking at her or a reversed image of her down the center line. So Marilyn Monroe, Sidney Crawford have this left-right asymmetry to them. That thing is like the weak force. It's the only thing that can detect this difference between left and right. And the weak force is the thing that prohibits a normal mass, that forces us into a Higgs mass through something called a Yukawa coupling. So that's the whole reason that it's in that thing, is it's a crazy Hail Mary to save all of physics. Because normally, if the world were left-right asymmetric due to beta decay,
I'm trying to play way more freaking files than it's playing. I don't know why it's not. It's only showing like 20 images. I must have put like 300. I don't get it. Whatever. So be it.
Thing that causes a neutron to decay into a proton and emit an electron and an anti-electron neutrino in the process. That process is the thing that denies us mass. And we would be at the speed of light, and we would all zip off in opposite directions, but for the Higgs field.
And that process is the radiative process. That's the process I call magnetism that that tears apart, that rarefies that which was concentrically drawn together through electricity. That weak force is an equal force to electricity.
Terrence, let me ask you a question.
That's what I feel.
I'm taller than Joe.
Right.
Imagine I challenge Joe to a fight. What do you think happens next? I get my ass kicked.
Well, Joe knows some shit that you
Joe
don't know.
knows some serious shit. I have an advantage on him in terms of weight. I have an advantage on him in terms of height. He's in great condition. The guy knows how to fight, and he's got a spinning back kick to die for, okay? What happens is I get my ass kicked. You do not know when you're going to get your ass kicked. And it's a big problem that you're going to keep courting, because I watch you. You keep finding the space where we could come together, and you insist on teaching into it. And it's like, I'm trying to be nice as pie because I'm inspired by what you're trying to do. But you have no idea like when you're fucking with a guy with an Italian last name and a shiny suit with a funny collar that you don't recognize. You got to stop.
Yeah, and I see the metaphor in it. And
Can I ask you, before we go on further, you feel that the theory of gravity is incorrect, and there's something else that accounts for all of the effects that we call gravity?
Yes, I feel.
And what do you think that is?
I feel that's electricity. I feel that gravity is the draft left behind from the electric force. As the electricity moves through, there's a draft that's generated because it creates whirlpools. Each of those whirlpools is the gravity or the cosmic foam, or I forget, there's another term that they were.
I don't understand why he's saying electricity while he's also saying the ether exists. Because he's pretty. Let me go back. He might have just been describing it, but in an electrical way when it's the ether. Like using electrons instead of ether to describe it. Maybe. Let me see.
Of the effects that we call gravity.
Yes, I feel.
And what do you think that is?
I feel that's electricity. I feel that gravity is the draft left behind from the electric force. As the electricity moves through, there's a draft that's generated because it creates whirlpools. Each of those whirlpools is the gravity or the cosmic foam, or I forget, there's another term that they were using for this foam, but it's a flowing.
Okay, pressure, pressure, blocking, shadow. Those are common keywords maybe to be looking for. None of which he's using. Ether.
Same way that thermals are effective by magnetism or radiation, creates these thermals that you're able to fly on. The opposite of those thermals, I believe that gravity is the opposite of those thermals in the electric force. It's the pulling down the same way the thermals push up.
What do you think about that?
I didn't even want to touch it. Because I'm going to get into the same thing. I'm trying to say to you.
I know, and I'm just saying, and I could be wrong, because based upon what I am putting together is taking commonsensical geometries and taking definitions of words and putting them together in a manner by which the layman sees it. Because the whole point is for everyone to understand science.
But you're teaching repeatedly. And that is going to be your downfall.
No, I'm listening. Right now, I'm a student. Now, I swear to you, right now, I am a student right now.
I don't know how you generate all that stuff. Like, I've tried to understand your mind. I try to do this. By the way, this isn't peculiar to you. So far as I know, I'm the only person who's tried to understand Peter White's theory of the universe, Garrett Lacey's theory of the universe, Stephen Wolfram's theory of the universe, your theory of the universe. My colleagues don't do this.
See, I thought I was special.
No.
You just made me feel not special anymore.
Brother, you are certainly special. That's not what I'm trying to say. What I'm trying to say is that physics and science is broken down. I will steelman you. I will try to put your best foot forward. I'm not out to get you. Where we are.
Did I mention I reacted to geometric unity? Only the popular ones. Those are the only ones that get consideration. That's not a good method, Eric. Not a good method.
Are right now is that the Brian Greens of the universe will not look at anything that isn't string theory. They're really like that. So whether it's Ed Witten or Sean Carroll or Neil deGrasse Tyson, this generosity of spirit of collegiality, it's dead.
Yeah.
Okay, and what you get is gotcha artists, right? And that's all they do. They're just trying. There's also something called gripe and swipe, where they try to find any flaw in what you do, so that they can throw you aside and then they can take every right thing that you did and put it under their own name.
That's why I patented. That's why I patented everything before doing it, because I thought that might be the case. Because
ideas are not patentable. I don't know what. All he needs to do is publish. Copyright and patents are not the same. If you write something and publish it, copyright, boom, done. Prior art, the end. You don't need a patent for prior art because it existed prior to the thing. It just needs evidence it existed prior to the thing, and if it existed prior to the thing, then it is prior art, which would be anything. It could be a writing, like a book. It doesn't matter. It doesn't have to be peer review. It just needs to be written and like in the public access to have like a copyright protection that just intrinsically is there because that's how we do as a people. At least the United States, I'm sure most of the world does that. I don't know. Where copyright is pretty much just standard the moment you write it, so you don't really need protection for an idea because the moment you write it, it's protected. You only need protection for something you're going to make money off of. That's an inventive physical thing or process to do something that you're going to make money off of because someone else is going to make money off of it. But like, if you don't and steal it, and so to protect it, you get the patent. But that's not what the purpose of a patent is in this sense. It seems to just be for added effect of like the sales pitch. I have 97 patents for protection, because it protects the ideas, even though that's really not quite like the realm of theory. Alright, anyway, let's keep going.
I went to somebody at MIT and I showed him the wave conjugations. I can't remember his name.
Because it's a small community. We all know each other.
Realistically, you need to know how the scientific process works, where like it's almost like a hierarchy. Like observation 1, like double slit experiment, for example. Not to put that at number 1, but like just an example. And like that's really a good example because of quantum mechanics is built off of it at its foundation. Like it really originates with the double slit experiment. Arguably not, whatever you want to say. I get it. But generally speaking, the double slit experiment is crucial and pivotal and central to quantum mechanics. And by knowing that, you can say, here's an alternative explanation for this experiment using this other theory, say classical mechanics, which happens to be pretty well established. And so therefore everything subsequent in quantum mechanics that relies on this foundational misinterpretation is all false. That's how you disprove a science. You can't just say, like, here's a thing, science disproven. Like, it has to address, like, the all distant redshifted galaxies. That's how you disprove the Big Bang. You can't just come at it some other angle. You need an actual explanation for all distant redshifted galaxies. And if you're trying to present a model that doesn't have an explanation for all distant redshifted galaxies, that means you've just assumed expansion of space and taken people's word for it because it's not true. And that means your model's already false. So, that's why it's important to really pay attention to details and think about everything as much as possible. But hey, what do I know? I'm probably just getting trolled by the world. Some Truman Show thing. So, talking about paying attention to details.
I will remember his name by the time I'm done. But But he said, "Oh, I've seen these before," and I was like, "No, you would. No, you haven't, because if you had seen them, I wouldn't have the patent."
So this is part of the problem: is that what you need? This is a very important digression. You need help from the community.
Yes.
But the community also sees you as a 17-year-old blonde girl from Minnesota getting off the bus in the Sunset Strip, having no idea where she is.
Even though I've got the 97 patents
Does
and
not
all
matter,
of that stuff,
because first of all, you can't.
Oh, 97 pad. There's the defense. He doesn't. It's a valid point. It's good he's being honest, and like really to the crux of it. Let's see, who's this?
Cannot patent science. They took away our ability to earn a living from doing science, right? You can do technology and patent it, but you cannot patent fundamental mathematics and physics.
Well, see, that's what I'm hoping. I'm hoping that
You're
they
trying to-
ultimately
but
take the
you're also
patents
trying-
from me, because they become basic
Terrence,
general.
let me tell you something. It is more important that you get a small number of us to say he did something than you fool some patent examiner who has no idea what the hell's going on and can't actually earn a living the way he dreamed of being an engineer. And so, at some level, the most important thing that you've done is weirdly based on an error, so far as I can tell.
Oh, damn, that was rude. Can't or fuck that shit. That's why most people, and most of them are lawyers, really. But with engineering degrees, it's way better than being an engineer. I'll give it that.
So, can you bring us a linchpin?
Bing, 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 bing.
Okay. And Jamie, could I trouble you for bringing up that same page over and over again? I'm sorry about that, brother.
But it is well said. Easy to fool a patent examiner. Not fool, but just fool. Play the system is what he kind of put it on the patent examiner, but which you can see who examined all of Terrence's patents. It's published on the document, so he's kind of singling them out. What do they got to do with this? It's really the process. The process is that the global system uses patents, and patent attorneys have figured out how to play the system. It's not complicated. And he got a patent attorney, so the end.
Bring one.
No.
Okay.
Can't we?
But we're dead air here.
Okay.
Okay, Howard's linchpin. Howard's extraordinary claims for the linchpin appear to mirror Green's extraordinary claims for the string.
So let's look at Terrence Howard filling up the dead air here, talking about the linchpin.
Okay.
The linchpin is the lowest common denominator of all matter, either seen or unseen. The linchpin is the internal dimensions of a torus. The linchpin is the universal wave conjugator for all things matter. It is the true currency of the universal flow because it is the common factor of all things. It is the smallest. It is the measurable constitution of a quantum or quanta, the smallest reflection, ultimately in collective potential of all things, which equals the multiverse. Blah blah blah. Let's now just watch our friend Brian Greene do the same thing. It's a great expression on Brian's face.
String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like a string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear.
I'm gonna skip this part. I don't want this again. Just in case. You never know. I think World Science Festival is largely Brian Greene's stuff, so he's probably, maybe it's a little more lenient, but you never know.
Strings.
Okay. Now, if you take what he just said, this is entirely respectable. This is a Columbia professor lecturing me for 40 fucking years about what they're going to do one day when they grow up. That everything is just a string, and just the way a violin can vibrate in different modes. All of the particles come from this excitation of the string. It's exactly how you sound with the linchpin. Now, string theory is not a terrible idea initially. It becomes a terrible idea when the string theorists suggest that nothing else has happened for 40 years, and they've sought to kill off every single person who has pointed out that there are other ideas and that they don't listen to their colleagues. And so, in part, you're going to incur an emotional penalty from me with the linchpin, which is a terrible thing because the linchpin is actually incredibly cool. So the same basic pattern, which is one thing explains it all, has a terrible kind of
Because I'm about to get you. I'm about to get you.
But my point is, this thing that you created is based on an error. And it's a beautiful error. And I think people are just not going to grasp it.
What's the error?
The error is that the arc cosine of minus 1/3 is not equal to 3/5 pi.
Garlic makes my feet stink.
Okay.
That was perfect.
Okay.
Terrence with the timing today.
I'm sorry. It may be the whiskey.
It is the whiskey.
But I'm not mad about it at all.
Right.
No, it's hilarious.
So what's going on is that inside of a tetrahedron, if I understand you correctly, I've got these vectors that point out towards the vertices. And between any two vertices, any of the four vertices, there's one of the 6 edges.
Right.
What's the angle between those two vertices as measured from the center of mass inside of a tetrahedron?
Still be at 120 degrees.
No, it's the arc cosine of minus 1/3.
That's what you're talking about.
That's what I'm talking about.
Okay.
Now, you say this is an undiscovered geometry. Now, why is that an undiscovered geometry?
Well, because they gave me the patents.
No. You got to stop that with the patents.
I did the patents because I have watched so many people come and take somebody's work. So it was a protection.
Okay, we've covered the patents.
Okay. My claim is that what you discovered is a little bit like even temperament. Now, even temperament is a lie.
Right.
Do you know about even temperament?
Yes.
Okay.
Yes. They're going up to 440 instead of 432.
Well, no.
Keep retucking it back together. It's an attempt to modulate or keep everything, start right back at the beginning and avoid the Pythagorean comma, avoid the necessary expansion.
Now we're talking the Pythagorean comma. The difference. All right, Jamie, can we get the 12th root of 2 raised to the 19th power?
Good luck with that, Jamie.
Come on, Jamie.
Well, show it on a calculator.
All right, I'm going to do this Terrence Howard style. There's a flaw in all of mathematics and all of music. Take out your calculators. They won't allow me to project it right off. So if we take the scientific calculator, turn it on its side, take the number 2. Okay, 2. Now we have an x root y. Can we find root right below that? Yeah.
Try it again. 2.
Okay, 2 x root y, and then do 12. Just type in 12.
Hold on, sorry. I was going to show it.
Okay. And now raise that to the 19th power.
That's this one, right?
Yeah. Oh, shit. It's almost 3.
The speed of light.
It's almost 3. It's 2.9966. That is, if we take the national anthem, can you sing? I think you can. Give me Oh Say.
Whoa, say.
Okay, now take from Say and get me to Land of the Free.
To the land of the free.
Okay. That is supposed to be the ratio of 3. But if we did it on a harmonica, and the harmonica was properly tuned, sorry. That's not going to be 3. It's going to be 2.9966. Because the reason we divided that octave into 12 parts is that we couldn't figure out how to get 3 to be perfect because what you said, Pythagorean comma, which most people don't have any idea of. By the way, you have to get Jacob Collier on the show.
We call it the percustrian fifth because when I put these together, you'll see that there's points where they will not connect because everything is expanding by phi, and that expansion.
You've got a Pythagorean comma in the middle of your linchpin.
Yes, I do.
Yeah,
with 109.47
rather than 108.
Yes.
You bastard.
Yes.
Yeah, that's why I caught you.
Okay, well you didn't catch me. I just used a little thing that they don't know about.
No, I know about and the reason.
But
wait.
I ain't going.
Terrence, come back here, Terrence.
I'm about to bring you something. We're talking about
Terrence.
I'm coming,
Terrence,
I'm coming,
come with.
I'm coming. I promise you. I'm coming right over to you. I just want to have these so when it's time to
Terrence, I don't think you understand the dead air principle at the JRE.
dead air principle. I'm here. As long as I'm here, everything is well and alive.
Terrence, okay. So the reason that you came up with an undiscovered geometry is that you figured out something that is analogous to even temperament, which is if you shove a pentagon, which should have 3 radians distributed around 5 angles.
Okay, just interrupting for 2 seconds, and let me play now.
In degree terms, that's 108. But the angle between the vertices of a tetrahedron is 109.47 and change.
0.47.
And so
I'm sorry, that was ridiculous. I'm just interrupting and play. Like, I feel obliged because my video got taken down. Isn't that stupid? What was he saying? There we go.
In degree terms, that's 108. But the angle between the vertices of a tetrahedron is 109.47 and change.
0.47.
And so effectively, the same game that we played when people like Bach started playing with even temperament is, where do you pay for even temperament?
Well, you end up paying for it in the expansion of the song. It does not follow a natural
That's true.
expansion.
There's no circle of fifths. There's what? A spiral of
there's
fifths.
a phi.
Yeah.
There's a phi.
And you know what the worst note is? The worst note?
It's C and B and E and F hitting at the same time.
No. You're saying something different. I mean that in the do, re, mi, fa, sol, la, ti, do, right? Do to me is an abomination, right? Can we do I can turn?
Yes.
Left a good job in the city. Let's go.
Left a good job in the city,
Okay.
working for a man every night and day. But I never lost a minute of sleep, thinking about the way things might have been. The wheels keep on turning, Proud Mary, keep on burning.
Keep on burning now.
Rolling,
Oh Lord.
rolling,
Oh Lord.
rolling down the river.
Rolling on the river. Okay. It's basically.
Sorry, I know I've been like an asshole, so I'm like, oh, let me play this. No, fuck that guy. But that was nice, man. That was nice, bravo.
Mary had a little lamb, right? But it's much cooler. Now, left a good job in the cite. Cite is going to be the third, and that third is wildly sharp to the Pythagorean third. That's the penalty we pay for dividing the perfect octave, right? Can you give me somewhere in Over the Rainbow?
Somewhere over the rainbow, birds fly.
Way up high. Let me see, what would it be?
I feel like I'm in a boxcar.
I feel like I'm in the launching pad where the UFO lands on Close Encounters.
All right, somewhere is a doubling of frequency, right?
Right.
The doubling is perfect. The fifth is a lie, but it's a good lie. The third is an abomination. It's not until you get to 53 notes, which the Turks use, that you get a better fifth and a better third. You get a better fifth at 29 notes per scale.
Yes.
And you get a worse third. So there's no reason to do
It's the
that.
12th, the 29th, 53rd.
Yeah. Now, my claim is that you pulled off the same thing by finding a cheat inside of the linchpin, which is why it's genius. And I don't even think you know how genius this thing is my guess.
I'm about to show you noble gas,
Oh,
and
stop
I'm
it.
going to show
You're
you
gonna
matter.
fuck the whole thing up.
So,
Listen to me. The number of edges in a tetrahedron is what?
and the tetrahedron is 6.
And that's why you have 6 pentagons. But these 6 pentagons are not, either they're not perfect or they're not joined perfectly. You put 6 motors in these things with propellers, and you have 6 degrees of freedom.
Here you go.
You have an object. So we talk about pitch, roll, and yaw. But those are basically, if I understand correctly, the basis vectors for the Lie algebra of SO3 or spin 3 or SU2.
What's Lie algebra?
Well, so the idea is I have a rotation group of symmetries of this object about its central vertex. Okay?
Right.
And that's one of the things. You can put one of these things up, and with 3 degrees of freedom, I can spin it, right, like a full-on UFO, and just have it moving in crazy ways that nothing else can move. Because a quadcopter has only 4 degrees of freedom because it's got the 4 motors.
This is unlimited.
Okay. Well, but it's going to distract us. Let's get to that in 1 second because it's super cool.
Okay.
By the way, that's a CGI.
Yes,
but I've
that's a
actually
CGI.
seen,
I'm
I've
showing
seen
you the
guy
real
actually flying this around, so I don't want to do
We've
this.
got like 19 of them. That's actually.
So what's going on with this is that you have 3 degrees of freedom, which is the rotations that I need here. But you've got 3 extra degrees of freedom to move in different places. Now, there's something called the affine group, which is the semi-direct product of SO3 with the R3 group of translations.
And SO3 has 8. It introduces the chromatic aspect of.
Don't go chromatic. Just
Don't go chromatic,
You've got
okay.
something brilliant.
Okay. I'm listening. I'm just trying to understand.
The best thing that I've seen out of Terrence Howard, I will tell people, this is why you never throw the baby out with the bathwater. And again, I don't know that you invented it. I think you did.
I did invent it.
I promise you, I think
No,
you
I
did.
didn't invent it. It was given to me. An angel gave that to me, and I'm sorry that everybody.
Terrence, I'm sorry to say this. There's a way in which we all feel pressure to give away the genius stuff that we do to some higher power. This is why if you ask like Khabib Nurmagomedov, like, how do you do such great things? He'll say, mashallah, or astaghfirullah, right?
Inshallah.
Alhamdulillah, right?
Inshallah.
Because Islam is very good about, you always give away the compliment because you can't hold it because it'll cause you an ego distortion. This thing here has 6 degrees of freedom based on the relative speeds of the motors that you put into it. Plus, there's an affine group called SO3 semi-direct product R3, which has 6 Lie algebra elements. That means that this thing can potentially span the Lie algebra. And if you have a trackball over here as a controller, and you put like 3 theremins so that you could control in 3-dimensional space, you could potentially have a drone that can rotate itself in 3 dimensions and get anywhere based on these 6 objects. Now, I could be wrong about that.
No, you're right. We've actually done that. So,
Okay. So my claim is, if the only thing you've done, forget the art, forget the science, forget the this, forget the that, if the only thing you did was to introduce an error which is 109.47 is not exactly 108.
But 108 is that key of A, which is.
God damn it, you won't stop.
I'm not stopping. I'm working with you.
I know.
Keep going. All right, you talk.
That is a really cool grade A idea until I hear that somebody else did it, or that when you machine this, because this is the thing.
Now, this is when you put four of them together.
Now, the thing is, it's very cool if you take what Intel does with drones, where they sort of synchronize these swarms. This thing comes together, and it forms a stable structure. Now, if you look at it, the tolerances that you've built into this thing, because these pentagons do not exactly come together.
109.47.
It's not 108. That thing, within engineering, is like even temperament. Even temperament is a lie. It's a fraud. But, oh my God, all the most beautiful music in the world is built on even temperament.
But look at what it generates.
That's what I'm talking about.
You put four of these come together and make this. 4 of these come together and they make this larger structure that is the same exact thing. So that's not
Terrence,
a lie.
It is a lie.
This
You're
right
trying to
here
build the
is-
whole universe off of the
I'm
linchpin.
defining something new.
You are. To the best of my knowledge. By the way, I looked at this years ago. Wait.
Hold on. No. Before you go there, this is the other side of it.
Yeah.
This is.
Okay, dudes. Before they go there, good point. I'm gonna end this. We got an hour left, a little bit less. So this will probably be 4 videos, and exactly, trying to build the whole universe on it is like a leap. It's a leap. Alright. Till next time. Thanks for watching. See you. Peace.